Ever wondered how artificial intelligence or AI actually works? How does a machine think, learn, and even create like a human? Today on Knowledge Hub, we're breaking down the fascinating inner workings of AI, from the math to the magic behind it. At its core, AI is all about making computers mimic human intelligence. But how do you teach a machine to think? It all starts with data, and a lot of it. Every photo you upload, every voice command you give, every sentence you type, all become raw material that AI systems use to recognize and learn patterns. Think of data as the experience that fuels artificial intelligence. The more high-quality data an AI sees, the smarter and more accurate it becomes. The heart of AI lies in machine learning, the process that allows computers to learn from data instead of relying on fixed rules. In traditional programming, humans define exact steps. If this happens, then do that. But in machine learning, we give the system examples and let it figure out the rules itself. For instance, to teach an AI to distinguish cats from dogs, you feed it thousands of labeled images. The model analyzes the shapes, colors, and textures, learning which patterns correspond to each label. Over time, it can identify a cat or dog in a new picture it's never seen before. That's learning in action. Now comes the true brain behind modern AI, neural networks. These are mathematical structures inspired by how the human brain works. A neural network consists of layers of artificial neurons, each performing tiny calculations. These neurons are connected by weights, which determine how strongly one neuron's output influences another. During training, the network makes predictions, compares them with the correct answers, and adjusts these weights through a process called backpropagation. This constant fine-tuning gradually minimizes errors, much like how our brains strengthen or weaken neural connections as we learn. To illustrate, imagine a neural network processing an image. The first layer detects edges and colors. The next layers recognize shapes like eyes or wheels. Deeper layers combine those features to identify complex objects, like a cat, a car, or even a human face. This layered learning approach is what we call deep learning, and it's what makes AI capable of understanding highly complex information. Deep learning is the backbone of today's most advanced systems, from speech recognition and language translation to autonomous vehicles and medical diagnostics. Large-scale models like GPT, BERT, or DALL-E are trained on enormous data sets, sometimes terabytes of text, images, and audio, using thousands of GPUs working in parallel. During this phase, the model fine-tunes billions of parameters, optimizing them using mathematical functions like gradient descent, which helps find the best possible solution by gradually reducing errors. Once training is complete, the AI enters the inference phase, where it applies what it has learned to make predictions or generate responses in real time. For example, a chatbot answering your question, a camera focusing on your face, or a car detecting pedestrians, all of these are inference tasks running on optimized neural models. Underneath this all lies the mathematics of intelligence. Linear algebra helps handle data as matrices. And vectors, calculus drives optimization and learning, statistics helps understand uncertainty, and probability theory powers decision-making. These mathematical foundations enable AI to reason, adapt, and improve, not by magic, but through computation. However, it's important to understand that AI doesn't truly think or understand like humans. It doesn't have emotions, awareness, or consciousness. It simply identifies patterns and correlations based on previous data. That's why human oversight is crucial, to ensure AI stays unbiased, ethical, and transparent in how it makes decisions. So next time you unlock your phone with your face, get music recommendations, or talk to ChatGPT, remember it's not guessing or reading your mind. It's using layers of data, math, and algorithms trained over millions of examples to predict what's most likely correct. If you enjoyed this deep dive into the world of AI, don't forget to subscribe to Knowledge Hub for more about the science behind the world's most advanced technologies. And as always, stay curious.